Welcome, my name is Adrian May and I'm wearing my jazziest polo neck today because we're going to tackle something I know that everyone hates. So I'm trying to make this a little bit more exciting and a bit more fun. It's not going to be. We're going to look at fractional exponents. And these are types of questions that, especially in the ACT, they're the questions that look like this. They're like horribly dense, horribly cramped, and they look awful. They look really intimidating. However, if we take questions like this and we just look at each term one at a time and we know how to develop a few exponent rules, they're actually fine. These questions are also very important right now because fractional exponents is quite a trendy question type right now. It turns up quite a lot in the ACT and the SAT. So it's worth doing, it's worth paying attention to. A lot of people tend to zone out halfway through, they're like, oh, it's too hard, it's too dense. But stick with me, it's going to be fine. We're going to work through one or two simple practice questions and then I'm going to show you one or two ACT exam questions, and by the end of the video you're going to be able to solve them. It's going to be totally fine, and that's going to be one thing off your list of topics you need to know for the SAT and the ACT. Okay, you ready? Let's go for it. Okay, so let's start looking at what a fractional exponent will do and what it means. And I always want to start with x to the power half. What can we do with x to the power half? And actually what this means is x to the power half is the square root of x. Now, so far so good. Now what I want to do here is add, in the square root of x, I want to add a little 1 here and a little 2 here. Now when we write the square root of x, we don't really write this. We don't write x to the power 1 and we don't put a little 2 on the square root sign. But it's useful here to help us track where the numbers go. The 1 on the top of the fraction drops inside of the square root sign, and the 2 on the bottom of the fraction then sits outside of the square root, so the square root of x to the power 1. And tracking these numbers into the right spaces is all we have to do for every other fractional exponent. So to give you another example, if we had x to the power 7 divided by 9, how is this going to work? Well, again, we're going to track the numbers in the same way. We're going to write a square root sign and x inside. And then the 7 from the top of the fraction is going to drop down inside the square root. So we're going to have x to the power 7, and the 9 is going to sit outside the square root sign. So we can have the 9th root of x to the power 7. And that's converting from a fractional exponent into a surd. We can also look at how to convert surds back into fractional exponents. So if we have the 4th root of y to the power 3, how are we going to convert this back to the fraction? Well, we're going to have y to the power of 3 on the top of the fraction divided by 4 on the bottom. So this is y to the 3 over 4. Things can get a little bit more complicated when we have top-heavy fractions. So, for example, if we had x to the 8 over 5, we could write this as the 5th root of x to the power 8. That's totally fine. That is true. It's what it equals. However, the SAT and the ACT are usually going to want you to write this as a slightly different form because this is a bit confusing. We're raising 8 to the power 5 and then 5th rooting it. This feels a bit convoluted and back and forth, and we don't really know where we are in the scale of things. How big is this value of x? So we can write this in a bit of a neater way, and what we want to do to start with is think about this top-heavy fraction. 8 divided by 5, can we write this as a mixed number, as a whole number and a fraction? And how many times does 5 go into 8? Well, it goes into 8 one time with 3 left over. So 8 to the power 5 is the same thing as 8 divided by 5 is the same as 1 and 3/5. So we can rewrite x to the 8 over 5 as x to the 1 and 3/5. And if we remember our exponent rules, we can split this up. When we multiply exponents with the same base together, we add the exponents together. So x to the 1 and 3/5 can be written as x to the power 1 multiplied by x to the power 3 over 5. And so we've split the whole number and the fraction out from our exponents, and we can then simply write that as x multiplied by the 5th root of x to the power 3. So by separating the mixed number and the fraction into an integer exponent and a fractional exponent, we can now rewrite this as a whole number and then a surd exponent. And this is a lot simpler. We now know we have x multiplied by another low fractional amount of x, and so it's easier to see where we are on the scale of x's having done this. So to think of another example, if we had y to the power 11 divided by 4, what could this equal? Again, we have a top-heavy fraction, so we want to rewrite it as a mixed number. Y to the 11 over 4 is the same thing as y to the 2 3/4. We can split that then up into y squared multiplied by y to the 3 over 4. And once we convert that y to the 3 over 4 into a surd, that's the same thing as y squared times by the 4th root of y to the power 3. And again, this is a slightly neater way of understanding where we are in the scale of surds. So let's do 2 ACT questions that are quite messy. They look quite ugly, but as long as you remember how fractional exponents work and how to convert surds into exponents and back again, we're going to be totally fine. Now, so this question's quite dense. We have a lot of G's, we have a lot of H's going on, and all our answer choices look really similar. The best thing to do with this kind of question is just to take one term at a time. So we're going to start with the G's. What's going on with our G's? And we have G squared multiplied by the square root of G to the power 5. So the first thing to do is to convert that surd into a fractional exponent. So the square root of G to the power 5 is the same thing as G to the 5 over 2. So we can rewrite this as G squared multiplied by G to the 5 over 2. When we multiply exponents together with the same base, we add the exponent. So we're going to have G squared times by G to the 2.5. We add those together, and that's the same as G to the 4.5. We're going to leave that there for now, and we're going to move to the H's. And if you want to do the same thing with the H's, if you want to pause the video and try and manipulate that yourself, please do. Okay, so what do we do with the H's? We have h squared multiplied by the 4th root of h to the power 5. Let's deal with that surd. We can rewrite that surd as h to the 5 over 4. So we have h squared multiplied by h to the 5 over 4. And 5 over 4 is 1 1/4. So we have h squared multiplied by h to the 1 1/4. When we add those exponents together, we have h to the 3 1/4. So now we have our g and our h terms rewritten in different forms. We have g to the 4.5 and h to the 3 1/4. What we now know, looking down our answer choices, is outside of the surd, we're going to want to have g to the power 4 and h to the power 3. Looking down our answer choices, only answer choice H gives us that. So we already know that H is going to be the correct answer. But something might look a bit funny about this. We want G to the half and H to the quarter. H to the quarter we kind of have, but they put them both under one surd. And we have G squared, the 4th root of G squared. Now we were looking for G to the half. Is that actually the same thing? And if we think about it, it is the same thing. G to the half, G to the 1 over 2, is the same thing as G to the 2 over 4. 2 over 4 is also a half. The reason why they put G to the 2 over 4 rather than 1 over 2 is so we can put both the G and the H under one surd sign to make it a bit neater. Otherwise we would have to have the square root of G and then after that the 4th root of H, and that would look a bit messy having two surds stacked up. So they've combined these expressions together and put them under one surd. So we're going to look at that process again in one more question. So I'm going to put this on the screen for you. If you want to have a go at this question yourself, please do, and pause the video and have a go, and then we'll go through it together. Okay, so here we're multiplying x to the power 3rd by y to the power 5 over 4. And again, looking down on answer choices, one thing we want to notice is pretty much all the surds have a 12 outside of it. We're finding the 12th root of something. So it seems like what we want to do is to change the denominator of our two fractions into 12ths. And that makes sense because we have 1 over 3, 5 over 4. The lowest common denominator of 3 and 4 is 12. So x to the 3rd can be written as x to the 4 over 12 if we multiply both the top and the bottom by 4. And y to the 5 over 4 can be written as y to the 15 over 12 if we multiply both top and bottom by 3. So we have x to the 4 over 12, y to the 15 over 12. The next thing to note is 15 over 12 is a top-heavy fraction. So immediately we need to rewrite that as y, and we have 1 and 3/12. And so now we know what we're looking for in the answer choice is we want x to the 4 over 12. So we want x to the power 4 under the square root sign. And only answer choice is G and j give us that. And then we want y to the 1 and 3/12. That means we need a y outside of the surd. And that answer choice j gives us that. And inside the surd, we have 3/12. That is y to the 1 and 3/12. So our answer choice in this case is going to have to be j.
Okay, great. You made it. If you're still here, you must have made it all the way through the video and all the way through some of those more horrible questions. So good job. I hope that's going to make sense, and I hope that's helping you with this kind of question on the ACT and the SAT. If you want any further help, please obviously check out the other videos I have on my channel, but also get in touch if you would like some one-to-one lessons. I do lessons in London and Glasgow, but mostly these days over Skype, so I can help you wherever in the world you are. My website information is below, and if you want more lessons one-on-one to help you with any part of the SAT and ACT, not just math, but also the English, the science, the reading, essays, I cover all of it. So please get in touch and I'll be happy to help you in any way that I can. Please also obviously like and subscribe to my channel. If you have any topics I haven't yet covered or individual questions you want me to look at, please leave them in the comments below. I'll try and get around to that as soon as possible. Any other comments or questions you have, that will be really useful. And thank you for watching. Again, like, subscribe, get in touch if you want any lessons, and I'll hopefully see you all again soon. Have a good day.